Okay, so our very first counting problem is going to be this very simple problem. We're given a set A. The set A contains elements 1, 2, and 3. And we're going to ask ourselves, how many subsets of A are there in total? Okay, so this set is small enough that we can actually write every subset of this out and just count them. And how are we going to do that? We're going to use what's called a power set. So what this means is we're going to write down the power set of what? The power set of A. Now, what is a power set? A power set is simply going to be some big set with our beautiful curly brackets. And inside of this set is going to be every possible subset of A, right? So let's write that out. This will make a little more sense once I show you the actual example here. So the power set of A is going to be this huge set containing every subset. Well, what do we know? The zero or the empty set is always a subset of any set. So we can say that's going to be a subset of A. Fantastic. 1 is going to be a subset of A. 2 is going to be the subset of A. Okay, let's stop. What am I talking about? If you're lost, again, what we're asking here is, if you have something that's a subset of a set, you're saying, okay, if we're saying the set 1 is a subset of A, we're basically saying everything on the left-hand side of this symbol here is part of what's on the right-hand side. We know we know 1, the set of only 1 is a subset of A because 1 is an A. We know the set of only 2 is a subset of A because we know 2 is in our original set A. So with the same reasoning, we can also say the lonely set 3 is also going to be a subset of A. Now, we're not finished just yet. What other possible subsets can we think of A? Well, instead of just thinking of the lonely versions where you just take one element and you say, well, yeah, that's a subset of the big set because it's part of the big set. Well, what if we take 2, right? You can very quickly see that 2, or maybe let's not look at 2 just yet. You can very quickly see that 1 and 2, the little tiny set of 1 and 2, is a subset of A because 2 is in A and 1 is in A, right? Both of those exist in A, so if we just take 2 of them, they're going to be a subset of A. So we can write down the set 1, 2 is a subset of A. Similarly, you can then say the set 1 and 3 is a subset of A because 1 and 3 are both in A. And finally, you can say the subset 2 and 3 is a subset of A. Now, very important to note, when we're looking at sets, the order does not matter. A can also just be written as 2, 1, 3. It is the exact same thing. The order in which we list these elements does not matter. The elements just have to be the same, right? This set on the right contains everything on the left. Everything on the left contains everything on the right. If I instead wrote down something like 7, this would no longer be correct because 7 is not over here, right? Or if I wrote down something like B is not on the left-hand side. So in this case, the sets aren't the same, not because the order is different, but because the elements inside of these two are not equal. So that's a very important note here. Now, why am I saying this? Because a lot of people are going to make the mistake of then after this writing something like 2, 1 is a subset of A. Now, this statement is true. 2 and 1 is a subset of A because 1 is an A and 2 is an A. But with what I just said, the order doesn't matter when you're looking at sets. We've already said this. When did we say this? When we wrote this down over here. These are exactly the same. The set 2, 1 is equal to the set 1, 2. So as long as you've already written a set with all of the elements, you don't need to rewrite it in a different order. So we're not going to write something like 3, 1, and the set 3, 2, because we already have both of those over here, just in a different order. So do not repeat or rewrite these sets more than once. This is a very important note to have to make. Fantastic. Okay, so we've done the fact that a subset can have nothing. It can have one of the elements, one of each element. You can have two of each element in the original set. Well, the size of A is going to be what we call 3. What does the size mean? Well, it means how many elements there are, which means the biggest subset of A, and maybe I'll write a proof for this later at some point in my set proof playlist, is, of course, the last remaining subset is going to be the set containing all of the elements, 1, 2, and 3, right? We've gone from 1 to 2, and now we go to 3, and of course we stop at 3. You can't have more than 3, right? Because all of these are already in A. So all this set is a subset of A. In fact, this set is equal to A, and how would you prove that? You would say that the right-hand side is everything on the left, the left-hand side is everything on the right, so they're equal. That's not the question we're looking at, though. Remember, we're just caring about this one side. We're just caring that whatever we write in this huge power set is in A, which includes everything in A is also a valid thing to say, which is what we are in fact saying here. So there's nothing else to say, right? We can't say 1, 2, 3, 1. This is in fact, I'm pretty sure, I could be wrong, this is the same as saying this, because when you repeat an element, that doesn't count as a new element. Repeating 1 is still just going to be 1, or repeating 2 is still just going to be 2. You can say, you can add 300 3s here, right? And it still would be the same as 1, 2, 3, or 3, 2, 1, or 2, 1, 3, whatever you want to, however you want to write down this set. So there we go. We have now listed every possible subset of A. So we can now close this large bracket we started. And all that's left, because this power set that contains all of the subsets of A, and our question is how many subsets of A are there? Well, they're all here. All that's left is to count them, so we just have to count them. 1, 2, 3, 4, 5, 6, 7, 8. There are a total of 8 subsets of A in total. Now, another way to look at this is the size of the power set. So remember I mentioned the size of A is 3 because there are 3 elements in A. The size of the power set is also going to be the number of elements in this big set. Well, how many elements are there in this set? Is 1, 2, 3, 4, 5, 6, 7, 8. The size of the power set is also going to be 8. So in reality, this question is just asking you how many elements are there in the power set of our set up here, our set A. Okay. Now, something important to note, when you're dealing with large sets, if I made A 1, 2, 3 all the way to 1,000,000, you are going to be here forever writing out every single subset possible of A, right? So in math, there's actually a very nice shortcut you can use when dealing with subsets. If you want to know how many total subsets of A there are, right? Or basically, what is the size of the power set of the set we're interested in? You can use the formula 2 to the n. What does this mean? Well, this means that the number of subsets, the total number of subsets of this set, or the size of the power set of this set, is going to be 2 to the power of n, where n is the number of elements in your set in question. So how many elements do you have in this here bracket? Well, we go to A and we ask ourselves, how many elements do we have? We have 3 elements, 1, 2, 3. So this would be 2 to the 3, which is equal to 8, which is exactly what we got up there. So this is going to be a shortcut we're going to use. We're simply going to ask ourselves, well, if we want to know how many subsets there are total of a set, we're going to say, well, it's just going to be equal to 2 to the power of n And all that's left is to count, well, how many elements are there in the set we're asking about. In this case, 3, so n is equal to 3. If we had something like 72 and then 5, well, now we have 1, 2, 3, 4, 5 elements. So instead, this would be 2 to the power of 5. So that's how you kind of approach problems with subsets, and specifically when you're asked about the total number of subsets of a set.